Okay, so label that. Okay, we're also going to put our ratios on these triangles. Okay, so across from a 45 degrees is a x square root of 2, but we're just going to put square root of 2 on here. The reason for that is we're using the unit circle, so that x can be anything. Okay, it's a unit of ratios. And then square root of 3, or square root of 2, not 3. And the hypotenuse is 2x, or 2. So then on the 30, 60, 90, across from 30 is just, we're just going to put a 1. Because that's 1x, right? That's scalar. Across from 30 is, 60 is square root of 3. And hypotenuse is 2. Okay, these you should already know. I've told you for 2 weeks. You had to know these, yes? Yes. Okay, so that is what we're using today. I'm going to switch from my paper to the projector in a second. Your triangles do fit in here. Remember, all triangles in the unit circle. What is up with my camera today? All triangles in the unit circle are made to what axis?
X.
The x-axis. So if I put my triangle, I might have to turn it over. But if I put my 30 degrees here, does it fit in here?
Yes.
Yes. If I put my 60 degrees, does it fit in here?
Yes.
Yes. What about if I bring my 30 degrees over here? Does it fit in here?
Yes.
Getting that reference angle, right? That distance from the x-axis. And then I have what? 45? So you are going to be using these triangles as we go to get your orientation. So what I mean is, if I ask you for this 45, what is the x of this 45? Square root of 2. What is the y of the 45? Square root of 2. So this point would be what? Square root of 2 comma square root of 2. Okay. So I can have those on here. Or if I can, I don't know how. So I'm now going to switch so I can write and you can see the whole circle at one time. If I do just my paper, you can't see the whole circle at one time and it kind of defeats the purpose. So hopefully I can write small enough on here. So there's some things on here that I want to talk about. Up on each quadrant, I want to label the quadrants first before we start. The first one is what? Quadrant 1. And it is Q1, Roman numerals. I told you I'd count off on the test, and I did. Okay, then I have quadrant what? 2. Then I have quadrant 3. And quadrant 4. Okay, it says positive. So what functions are positive in the first quadrant? What? No, what functions? Sine, cosine, tangent, secant, cosecant. It has to do with the x's and y's, yes. But, so which one of those are positive in the first? All of them. So, personally, I'm just going to write all. And then negative, none of them, right? What is positive in the second quadrant? Sine. And when I say sine, it's also cosecant, yes? I'm going to talk about sine, cosine, and tangent only because what do you have to do to get cosecant, secant, and cotangent then? Find the reciprocal. Okay, so what's negative? Cosine and tangent. What's positive in the third quadrant? Tangent. And what's negative? Sine and cosine. All based on the x and y's where they're positive and negative, yes? Okay, what about the fourth quadrant? What's positive? Cosine. And what's negative? Sine and tangent. Okay, so these are just a little bit review before we start hidden in there. I'm really not how this is going. Okay, so you see on the inside of the circle, you have the degree symbols, and there's another line. So we will have degrees, and right next to them, we will have radians. Okay? So we're going to start off at 0 degrees. And what is my next line at? You guys just had your triangles. What triangle fit in there?
30, 60, 90.
So, but what angle was right here is what I was... 30. To get on that, put your 30-degree angle there and make sure that you see it. Okay, does your 30 fit in there?
Yeah.
Okay, so this first line is 30. What is your next one?
45.
45.
60.
And your next one is 60. What colors have I used? Okay, so what's the next angle?
60.
90. Okay, now I'm going to skip over here. What angle's this? See where I'm drawing a dot? What angle's that?
180.
180. And then I'm going to skip down. And this is 270. Okay, the reason I did those is because those are the quadrantal angles. They're not in a quadrant. They make the quadrants. Yes? Okay, so in radians, well, it's 0 degree. Oh, we forgot 1 degree.
360.
360. Really not liking this, but I don't have enough colored Expo markers. Okay, so if it's 0 degrees, how many radians is that? 0.
Yeah.
Okay, so 0 degrees, 0 radians. Well, we know 180 is what radians?
1.
Isn't it pi? So it's pi. So 0 pi, and then so 360 is how many pi? 2 pi. Well, if we have 0 and we have pi, what does that make 90? 1/2 pi, or just pi over 2? So then we're going to count half a pies. So I got 1/2 a pi, 2 halves a pi, 3 halves a pi. So 3 pi over 2. It is all about fractions. Sorry to let you know that, guys.
I hate fractions.
Okay, so we've got the quadrantal angles done. Well, let's go ahead and talk about the points. We'll do that. Okay, so what coordinate, if I went straight out right here come on, dot, dot, dot. Right here. What coordinate is that? At 0 degrees. What's 0? Well, 0, 0 is right here. So it's the unit circle, so I go over what? 1 unit and up what? 0. So that coordinate is 1, 0. Okay, I'm going to keep saying the unit circle. That unit is that X. That unit could be 28. It could be 30. It could be whatever. Got it? Okay, so then at 90, what's my point?
0, 1.
0, 1. At 180, what is my point? Negative 1, 0. At 270, 0, negative 1. Okay, so I've got those points there, yes? And if I were to ask you, what is the sine at 0 degrees? Well, sine is opposite over what is that? If I'm talking opposite, what's the radius of the circle called? If I put a little triangle in here, yes? If this is the opposite, the radius is called the what? It's on the board. It's on the board. SOHCAHTOA. So opposite and hypotenuse, yes? And this is adjacent. Okay, so sine is opposite over hypotenuse, or y over r, correct? Okay, so the y is what? 0. And the radius is 1 unit. So what's 0 over 1? 0. Look at that. It's right there. And what's cosine? X over r, or adjacent over hypotenuse? Yes? Well, if my x is 1 and my radius is 1, I get what? 1. What if my x is 28 and my radius is 28? What do I still get? 1. So this point is the sine is the y and the cosine is the x. So that point is essentially cosine sine. So if I ask you for the cosine at 0 degrees, you're going to tell me it's 1. If I ask you for the sine at 0 degrees, you're going to tell me what? 0. What is the x at 0 degrees? 1. And x is cosine? Okay. So same thing going on. What is this cosine at 90 degrees? 0. Because cosine is what value? X. What is the sine at 90 degrees?
1.
What is the sine at 270? Negative 1. What's the cosine at 270?
0.
What is the cosine at 180?
Negative 1.
What is the sine at 180?
0.
0. You've got to know that. Should it be that hard to do?
No.
No, because you're just going out 1 unit if you would draw your own little circle, right? Okay. Well, right there is 1, 2, 3, 4. No, 1, 2, 3. 12 points of that 75 that I told you about at the end of the year. Okay, so next we got to go on to what? 30? Okay, so I want you to lay your little triangle in there so you can see if you need to label both sides of the triangle so the 30-degree angle fits on the 30-degree angle, do that. I want your triangle, the central angle, to be at the central angle. That makes a lot of sense, right? Here, your 30-degree angle needs to be here, and so then your triangle. So you should be able to see what on the x-axis? What ratios on the x-axis? No. Not 2. Yep. Should be square root of 3 here. And what across from the 30? 1. And on your radius, it should be 2. That's how your triangle should look. You got it placed there so it looks that way? Jaden, you're looking at me like I'm crazy.
I think I made my little triangle wrong, Miss Mick.
The little angle should be 30. You'll probably have to label both sides.
I think I might.
Yeah, because it won't fit in there. Like you have to turn it. You have to turn it over to make it fit. Okay. We got it now, Jaden? Okay. Everyone else got their triangle in there?
Yes.
Okay. So, when I ask you what the cosine at 30 degrees is, cosine is what value? The x. So what is the x at 30? Square root of 3. So you put a square root of 3 over here. And it's going to be square root of 3 over what? What's r? No zeros. 2. We're off the axis. There's no zeros. Okay? So if I ask you the sign, sine is opposite or the y. Yes? And what's the y? 1. And the radius is 2. So we're building this unit circle. It is an aid. It is not a crutch. Okay, what's the difference between an aid and a crutch?
Aid helps you, crutch you lean on.
Right. Aid helps you get there, right? And so it's going to help you get there to learn it. A crutch, you're looking at it every second, and when I hand you that 75-point table I'm talking about at the end of the semester, are you going to be able to do it? No. The sooner you know these, the better. But what did I just relate those to? That 30, 60, 90 triangle that you already knew those ratios, correct? Okay, so the cosine at 30 degrees is the square root of 3 over 2. The sine is 1/2. Because the opposite or the y and the adjacent or the x. You see how I'm using opposite and adjacent? I got this wrong. Opposite, adjacent, x and y's instead of just one or the other? Because those need to be interchangeable. But when I'm saying opposite, your angle is always at that central angle. Remember talking about that angle in standard position? That's where we're always going to put our angle. Okay? So, the next one we're going to go to, we're not going to go around the circle at all. I want you to find me another 30-degree angle on this circle. Now remember, it has to be sitting on the x-axis. You can't bring your triangle off the x-axis.
The one in the quadrant 2 right across from the 30 angle, just
Right here. I keep putting my eraser. Right here, isn't it? Find me another one.
Right under that.
Right under that. Because your triangle's fitting in there perfect, isn't it?
Yeah.
Okay, give me another one.
The one under the first one.
Right under the first one. Because these are all how far away from the x-axis, guys? What's the angle between it and the x-axis? 30 degrees. 30 degrees is that reference angle. Reference angle is the distance from the x-axis. It's a positive acute angle. So what that does for us is amazing things, guys. No matter what the angle is, as long as it's 30 degrees away from the x-axis, guess what the x is and guess what the y is? This point. It is the square root of 3 over 2 and 1/2. The square root of 3 over 2 and 1/2. And the last one is Square root of 3 over 2 and what? 1/2. But there is one thing different. What would that be? Positive and negatives, right? So in the second quadrant, are they both negative? One negative? Which one? The x is negative. So that means the cosine's negative, yep? Okay, what about on quadrant 3? They're both negative. What about in quadrant 4?
Y.
The y's negative, so the sine's negative. So if I knew 30, would I know all those other 3 angles? Yeah, we just got to figure out how much those other angles are. If this is 30 here, then what's this?
$180.
160.
No. If this is 30, right in here,
150.
it's 150. How'd you figure that out, Bladen?
Because
Minus
30 minus, or 180 minus 30.
180 minus 30. It's 180 minus your reference angle. Your reference angle is 30. So it's 150 degrees. Okay, what's the next one down?
210.
How'd you get 210?
Add 30.
Add 30. What about the one in the fourth quadrant? 330. How'd you get that?
minus 30.
From what? 360, because it's all about what axis, guys? The x-axis. Okay? Now we've got to get the radians for that, don't we? Now we have a formula. We could multiply by pi over 180, but I don't want to do that every time I have to do one of these. Do you?
No.
No. Okay, so we know that 180 is pi, correct? How many 30-piece pieces can I put in that circle from 1 to 180? I don't want you to answer. I want you to do it. Take your triangle. How many how many times can you move it 30 degrees between 0 and 180? Start at 0 and place it in there like end over end. You know what I mean? Six. You can fit it in there. Did you all fit it in there 6 times?
Yes.
Okay, so 30 degrees is pi over what? 6. I have 1/6 of pi. Make sense? Everyone get that 1/6. Okay, so now if I go over to 150, I'm 1 piece short of a whole pi, correct? And if my denominator is 6, what's 1 piece short of a whole? 5. So it's 5 pi over 6. Again, it's all about the x-axis, isn't it? So now I'm going to go to this next angle. I'm 1 more than a whole pi, correct? So it's still over 6, and it's 7 pi over 6, because I'm 1 more than a whole pi. You're going to hear that a lot from me. 1 less, 1 more, 1 less than 2. Okay, so the next one is 1 piece less than 2 whole pi, correct? So, obviously the denominator is 6 on the bottom again, correct? So if I had 2 pi, my numerator would be 12, so 1 less would be 11. So there's 12 more points. This chart doesn't seem too bad, does it? Because if I know 30, do I know 150, 210, and 330? Yeah. Okay, I want you to take the next angle we have going up is 45, yeah? Okay, so I wanted you to take your 45 triangle and place it in there. Make sure your bottom is on the x-axis. Cadence keeps trying to not put her bottom on the x-axis. It has to lay on the x-axis. No. No, not your hypotenuse.
What do you want from me?
I want you to put it like this.
It's 4.
We have 2 minutes left.
I want you to put it like that.
4.
No. Yes. Okay. Got it? Everyone got their triangle sitting there? Okay, what's my x? Square root of 2. What's my y? What's my r? 2. So my cosine sine point is square root of 2 over 2, square root of 2 over 2. Correct? Okay. We don't need the circle. We know these two triangles, correct? Yes? Okay. So then we got on the next 45 degree right here, we got what? Square root of 2 over 2. Negative what? X. So negative cosine, right? And then our next one, we got what again? Negative square root of 2 over 2 and? And my next 45 degrees?
Square root of 2 over 2 and then negative square root of 2.
Okay. So, got 1 minute. We're going to finish these guys before you leave, and your assignment's going to be to do the last one. What do you think it is? 60. Okay, so we got to get radians, yes? How many of these can we fit in 4? 45 goes into 180 4 times if you do the division, yes? Yeah. So it's pi over what? 4? Well, we're going to do radians and degrees at the same time, I guess. So 145 less than 180 is 135. Let's just go ahead and do the degrees. So then 45 plus 180 is 225, yes. And 45 less than 360 would be 315. So then 45 is pi over 4 because 45 goes into 180 how many times? 4. So we're 1 less than a whole pi, so it's going to be what pi over 4? 3 pi over 4. And then it's 1 more, so it's going to be 5 pi over 4. And it's 1 less than 2, so it's going to be 7 pi over 4. Because 2 pi would be 8, wouldn't it? Okay, so your assignment is to do 60. Got it? Okay.